Hi guys, a very good morning everyone. Welcome all of you to this session and welcome to the next practice session for the BARC 2024. Yes guys, the BARC is going to come up on 16th and 17th of March and we are having the multiple practice sessions for it around it. I mean, like already I've taken the practice session for digital, also for control system. Today we are having for signals, then Saket sir has taken for communication, Sanjay Rathi sir has taken for network. So all these different sessions will be going on for you parallelly. Right, very good morning everyone. Keep on joining. All right. Chalo. Yes, we can plan that also, Shashwat. Okay, regarding around for Bell. Hey, good morning Pradeep, good morning Likhil. Chalo. Yes guys, this is a regular introduction about me. Let's get moving ahead. You can also be connected in my Telegram. I'll share you the link also directly at the end of the session. Okay. So yes guys, now important updates first and then let's get started with the first question. So yes guys, Wednesday 6th of March at 7:30 p.m. Wednesday 6th of March at 7:30 p.m. Dheeraj Sardana sir is bringing you a step-by-step guidance workshop to ace GATE 2025 in the first attempt. Yes guys, now the fight for GATE 25 has started and if you want to be top in that fight, do not forget to attend this workshop. Okay, on our Byjus exam prep app at 7:30 p.m. Right. Also guys, there is a national scholarship test for coming up for all of you. That is on the Sunday 10th of March. Okay, and that's going to be live from 9 a.m. to 9 p.m. That means you can appear at any time as per your convenience. And if you perform well, you can get as much as up to 90% scholarship on our preparation program. So do not forget to register now and appear in the scholarship test. And also guys, this is the schedule as I already told you. So guys, some of the sessions are already conducted. Now next, we are into signal and system. Next, analog and EMFT, again two more very important subjects for BARC. Okay, going to come up on 6th March and 8th March. That is Wednesday, Friday, alternates are having the session. Okay, now guys, coming up to the first question here, everybody. Coming up to the first question here. Come on, everybody. Let's check it out. Yes, let's check it out. Come on. Very good morning. Yeah, you can get this class PDF, Likhil. I'll share you in the Telegram, don't worry. Evaluate the function integral t squared delta 2t minus 3. Okay, so if you talk about the basic property, okay, now this is delta 2t minus 3. There are two ways of approaching this question. Okay, either applying the shifting and the scaling property. Okay, dekho, this particular impulse is going to be located at 2t minus 3 equal to 0. Okay, so t is equal to 3 by 2 and then, okay, delta AT is given by 1 upon modulus A. It scales the area of the impulse, 1 upon modulus of A, delta T. Okay, so accordingly the method number 1 is, okay, if you know the location of the impulse, first of all the area of the impulse will be scaled by 1 by 2. Okay, 1 upon mod A, so 1 upon 2. Okay, and then t square. Now what is the value of t? 3 by 2. You know that whenever any function is multiplied by impulse, okay, the value of the function attained will be that, okay, when you substitute t equal to 3 by 2. I mean, wherever the impulse is located. The function is t square, so you have to put the t, okay, which is deciding the location of the impulse, that is 3 by 2 and whole square. Okay, 3 by 2 and whole square. This should be the case. Okay, the answer is definitely not going to be in terms of t cube. I think there's an error. Okay, so this looks like 3 square 9 and by 8, 2 square 4 and 2. Now, there can be another way of approaching it. Okay, there can be another way of approaching it. Okay, what could be the another way of approaching it? उसको भी आप देख लीजिए. Okay, if you are not satisfied with the scaling idea, then what you can do is, okay, if you want to create a simple impulse, like you see delta t, okay, let me put down the 2t minus 3 equal to p, then you will have the version of delta p or dp sort of case, okay, delta p sort of case, okay. Now, if you differentiate on both the sides, 2 dt will be equal to the dp, okay. Now, accordingly, your integration is, now please look into the limits very carefully, please look into the limits, okay. Now, if t is equal to 0, p starts from minus 3, and if t is infinity, okay, infinity minus 3 is also infinity, minus 3 say infinity, t square, what is the t? P plus 3 divided by 2, p plus 3 divided by 2 whole square. What is the value of dt? It is dp by 2, okay, it is dp by 2, and what is delta 2t minus 3? 2t minus 3 is equal to p. Okay, and yahan likh diya dp by 2. Now kindly solve it up. You are going to get the same answer. Okay, integral ft delta t will be f0, na? Will be f0. Okay, again this is impulse at p equal to 0, which is within the limits of integration. So now if I put the p equal to 0, so 0 plus 3 by 2 whole square, right, into 1 by 2 is anyways there outside, 3 square 9 upon 8, same answer. So answer is D. Okay, so this can be another way of solving it. This can be another way of solving it. This can be another way of solving it. Done, ji? Next question. All right. Yes, very good morning, Vidya. Okay, the mean square value of the given periodic waveform. What is going to be the mean square value of the given periodic waveform? Okay, देखेंगे यहाँ पे. Now, mean square value. Okay, mean square value. Okay, what do you need to exactly calculate here? The mean square value. The mean of the square of the signal. The mean of the square of the signal. Okay, chalo, that's basically what you also call it as the average power contained in the signal. Okay, the average power contained in the signal, and that is going to be calculated as now. Okay, now in a way it is also equal to, if you want to go for the basic definition, integral minus t se t, for example. Okay, integral minus t se t, f square t, यहाँ पे f बोला है ना. Okay, f square t dt, okay, divided by 2t. Okay, divided by 2t because we are averaging out. So for what limit we have integrated? We have integrated from minus t se t. Yeah, you can also take it like this. Maybe you can integrate minus t by 2 se t by 2. Fix any period for which you are integrating. Okay, minus t by 2 se t by 2, f square t dt. So the total length of the interval now becomes t, and then you can divide by t, divide by the total number of observations. Acha, okay, in general, to generalize it, we put t tending to infinity. But if it is a periodic waveform, this is the general definition of the, average power. If it is a periodic waveform, then this P average is basically given by energy contained by the signal in one time period divided by the time period. Okay, energy in the one time period divided by the value of the time period. Energy in one time period. It is known as the energy in one time period. Okay, now what is the time period here? Let us start this positive spike here. Isko count karenge. This is at minus 0.3. Okay, and the next one is at 3.7. Okay, if I count from here up to here, okay, so the total time period is 4. Minus 0.3 units this side plus 3.7. The total time period is 4. Now, what is the energy within this one time period? Okay, this is a flat zero curve, so this does not have any energy. Okay, what is the energy for this portion? The energy of this portion, for any rectangular portion, energy is given by amplitude square into duration. That you should directly know. So what is the amplitude square? 4 into duration minus 0.3 say 0.7, total duration is 1. Okay, what about the energy of this portion? See, even though the amplitude is negative, but while calculating energy, we take the square of the amplitude, so it's going to be positive only. Okay, even if you consider minus 2 ka square will be plus 2 ka square into duration here is equal to 2. Okay. So, if I come back and write down the answer as I told you, energy in one time period divided by time period. So, in one time period, energy is 4 square into 1. okay, plus minus 2 का square into 2 divided by the total time period which is 4, तो ये हो गया 16, that is 8, 24, 24 by 4, answer should be, fourth time period, answer should be equal to the 6. The answer should be equal to what? It should be equal to the 6, correct hai? The answer is equal to 6, done hai. Okay, any confusion, keep asking me. Next one. Convolute the signal, very basic question, come on everybody. It's a very basic question, come on, get me the answer. Yeah, very basic one. Now, for that, first of all, what you need to recall is what is the convolution in the discrete domain? What is step convolution step? UN convolution UN is R of n plus 1, shifted ramp. In the continuous domain, in the continuous time domain, UT convolution UT is RT, but in the discrete domain, UN convolution UN is R of n plus 1. Okay, R of n plus 1. Okay, the shifted ramp signal. Okay, so now apply the time shift property. U of n plus 1. Convolution U of n minus 3. Okay, whenever signals are shifted, the effect of shifting will be seen in the output also. So here it is plus 1, left shift. Here it is minus 3, right shift. So दोनों को combine करेंगे. Your R of n. Okay, now n first will become plus 1 and then also be subtracted with minus 3 and then plus 1. Okay, so the answer is equal to R of n minus 1. Total हो गया 2 minus 3, correct. R of n minus 1, answer should be option number B. The answer should be the option number B. Done hai? Yeah, next question. If the signal xt shown in the figure A is fed to an LTI system having the impulse response ht as shown in the figure B, then what is the value of the DC component? Okay, DC component present in the output. How do you determine the DC component of the output? DC component ke liye you need the frequency information so that you can calculate the zero frequency term. Okay, now frequency information is available in the Fourier transform. So what is this DC component? Okay, let us say this signal yt. Let us say this signal yt will have some Fourier transform y omega. Okay, and the DC component is basically given by y0. Okay, y0 se mera matlab hai the value of the Fourier transform at the DC at omega equal to 0. Correct hai ji? The DC component on the output. Now, what is the value of y0? How do you determine y0? Chalo, come on. How do you determine y0? The value of the Fourier transform at 0 frequency is also equal to the area of yt. It is also equal to what? It is also equal to the area of the yt. Okay. Now, what is the area of the yt? Tell me. What is the area of the yt? What is the area of yt? Now, देखो area of yt it's not available. Maybe you can convolute and find yt. No, but you can apply the area property of convolution. Area of yt, okay, when yt is equal to what? Yt is equal to convolution of two signals xt and ht. So, area of yt should be equal to the area of xt is whole multiplied by the area of ht. Correct. Now, what is the area of the xt? Okay, triangular waveform, half into base into height I can apply. Base है 2, height है 2. Base is 2, height is 2. Base is 2, height is 1. This one is rectangle. So height simply base into height, that is 2 into 1. So final answer, this is 2, this is 2. Final answer should be 4 units. Answer D, I will mark it up. Correct. Answer D, I will mark it up. Correct answer is D. Next one. For energy signal ft and its time shifted version ft minus t, okay, which of the options are correct? Dekho, there is a signal ft. Okay, now the question is talking about amplitude spectra, phase spectra, and etc. Okay, there is a signal ft which may have some Fourier transform f omega. Okay. Okay, there is a time shifted version ft minus t. Okay, let gt be ft minus t. What is going to be its Fourier transform? G omega. Time shifting corresponds to exponential term, phase term in the frequency domain. So e raised to the power minus j omega t. This is going to be f omega e power minus j omega t. Okay, now what about amplitude and phase spectra? So dear, very simple logic that, okay, very simple logic that if g omega is f omega e power minus j omega t, modulus of g omega is modulus of f omega e power minus j omega t. Okay, but what is the magnitude of e power j theta term? That is always 1. Right, r e power j theta, r is the magnitude basically. The magnitude term is only mod of f omega. So amplitude, yeah, magnitude spectra is same. Now, what about the angle g omega? Phase spectrum, whenever two terms are multiplied, two complex terms are multiplied, their phase are added. So it's angle phase omega, okay, plus the angle e power j theta is theta. So the phase here is minus omega t. Okay, the phase spectra cannot be same. It cannot be same, you can say directly also, because time shifting, that's what is the role of time shifting. It produces the phase term that shifts, that creates a phase shift. Okay, so amplitude spectra identical, phase spectra are different. Answer should be B. Answer should be B. Done, Aji? So such conceptual and logical questions, you have to be ready about. Consider the function h of j omega equal to h1 omega plus j h2 omega, where h1 omega is an odd function, h2 omega is an even function. Then the inverse Fourier transform of h omega is what? Okay, let's say h of j omega या simply h omega बोल देते हैं. Let us say some signal ht has the Fourier transform h omega, and that h omega is broken into two parts. ठीक है, क्या बोला है? That h of omega is broken into two parts. Okay, that is h1 of omega plus jh2 of omega. Now there's something about even odd function. So let me first see the symmetry in h of minus omega. ध्यान देंगे. What is h minus omega? It's going to be h1 minus omega plus jh2 minus omega. Okay, now h of minus omega is equal to h1 minus omega. Now h1 omega is an odd function, so h1 minus omega is minus h1 omega, and h2 omega is an even function, so h2 minus omega should be h2 omega only. It should be h2 omega only. Okay. Now, if I take the minus outside here, h of minus omega is minus को outside लिया, तो h1 omega minus jh2 omega. Now this means that, okay, h plus jh, h1 plus jh2, this is h1 minus jh2 means conjugate of h omega. Okay, so what is h1 minus omega is minus of h conjugate omega. Conjugate antisymmetry is coming up here. Conjugate antisymmetry is coming up here. Let me take this point once again. Okay, we have h of minus omega coming up as minus of h star omega. Coming up as minus of h star omega. Conjugate antisymmetry. The Fourier transform is conjugate antisymmetric. Okay, the Fourier transform is conjugate antisymmetric. अब देखो ऐसा कब होगा? Okay, ऐसा कब होगा? Now, whose Fourier transform is h minus omega? H minus t. Whose Fourier transform is h conjugate omega? Whose Fourier transform is h conjugate omega? Okay, देखो, what you should basically know is if ht having the Fourier transform h omega, as per the time scaling property, time folding property, h minus t has the Fourier transform h minus omega. Time folding corresponds to frequency folding, and h conjugate t has the Fourier transform h conjugate minus omega. Okay, so if you are getting here h conjugate plus omega, यहाँ पे क्या आया है? h conjugate plus omega. यहाँ let me make it more simple. Let me call it as h omega. So what is h omega? Is minus of h star minus omega. Okay, now h omega has the Fourier transform ht. So now let's take the inverse Fourier transform on both the sides. This should be equal to negative of h star minus omega. किसका Fourier transform है? That is h conjugate t. Okay, the conjugate of a signal is negative of it, and that is only possible if the conjugate of a signal is negative of it. Okay, like z conjugate is minus z. Okay, z conjugate is x plus jy. Minus of z will become minus of x plus jy. अच्छा sorry, यहाँ conjugate लेना था left side में, तो z conjugate is x minus jy. तो देखो x minus jy is minus x minus jy, तो minus jy cancel, x will be equal to minus x, that is x equal to 0. x equal to 0 means z is jy, that means pure imaginary. So this is only possible if the signal is pure imaginary function. So that's what, now direct properties also are there. If a signal is real, Fourier transform is conjugate symmetric. If a signal is pure imaginary, then the Fourier transform is conjugate antisymmetry. Conjugate antisymmetry. Okay, the correct answer is option number C. Okay, correct answer is option number C. Right, Ji? And if that is right, let's move ahead to the next question then. What is the next question I have? Okay, there is a signal given to you, xt is equal to e power j10t for mod t less than 1 and 0 for mod t greater than 1. I can write down this signal as e power j10t, dhyan dena, e raised to the power j10t into 1, okay, for mod t less than equal to 1 and 0 hai na, so let me write it as e power j10t into 0 for mod t greater than 1. Okay, now let me take e power j10t outside, so I am able to express the signal as e power j10t, okay, into what? Into 1 for mod t less than equal to 1 and 0 for mod t greater than 1. Now what is this signal equivalent to? A signal which is 1 for mod t less than equal to 1. A signal which is equal to 1, mod t less than equal to 1. Okay, mod t less than 1 means t is between -1 to 1. Any value between -1 to 1, magnitude will be less than 1. Okay, so any value of t, if I take between -1 to 1, the value taken by the signal is constant. Okay, so what shape do you obtain here? And it is 0 for mod t greater than 1. Okay, for mod t greater than 1. So what is this? It is basically a rectangular waveform. Rect of how much? Rect of t by t, where the total base is 2. So we write it as rect of t by 2. We write it as rect of t by 2. Okay, so that means my given signal xt is e power j10t into rect of t by 2. Now pay attention. Now try to recall what is the Fourier transform of rect of t by t. Very important formula. Everybody must know it if you have studied signals and Fourier transforms. T sampling omega t by 2. T sampling omega t by 2. Okay, so if I now take rect of t by 2, the width of the rectangle is 2 units. So the Fourier transform is 2 sampling omega into 2 by 2. 2 se 2 cancel, so it is 2 sampling omega. It is known as the 2 sampling omega. It is known as the 2 sampling omega. Now I am going to multiply by e raised to the power j10t. Now exponential term in the time domain comes in the frequency shift. Time shift, there is an exponential term in phase domain. Frequency domain. Frequency shift, there is a corresponding phase term, exponential term in the time domain. So e power j10t into rect of t by 2. Okay, that will have the Fourier transform 2 sampling omega minus 10. Sign opposite hota hai. E power plus j10t, 10 units. So omega minus 10, right shifting by 10. Okay, so your answer should be 2 sampling omega minus 10. Answers are in sine form. So we know that sampling theta is sine theta by theta. So this becomes 2 sine omega minus 10 divided by omega minus 10. Answer should be option number A. 2 sine omega minus 10 is divided by the omega minus 10. Done hai ji? Correct. Chalo. Okay, before I take up the next question, guys, important update for all of you that yes, for 2025, the ground zero series, okay, that is to make you prepare from the zero, the basics. It's live on the Byjus exam prep app daily at 5:30 p.m. Different sessions taken by different faculties. Okay, so download the Byjus exam prep app if you don't have it and enjoy all the content of GATE 2025 and yes, keep fighting hard for GATE 2025. You have enough time and you can really fight hard and come up with your best results. Next question coming up here. The next question, guys, coming up here. The response of a linear time invariant discrete time system to a unit step input un is delta n. What is the system response to the unit ramp input nun? What is the system response to the ramp input nun? come on. देखो, the response, okay, to a unit step input is delta n. To a unit step input is delta n. Okay, so let's say there is a system, discrete system having impulse response hn. Okay, if you apply the input xn, it will produce some output that is given by yn, and yn is xn convolution with hn. Okay, now the next type of input coming up is ramp. Okay, convolution of ramp with any other thing it's normally going to be lengthy. So what we will do here, we will adopt the Z transformation here to solve this problem better. Okay, so Yn has the Z transform Yz, Xn has the Z transform Xz, and convolution in time corresponds to multiplication in the Z domain. Okay, so Xz multiplied by Hz, where what is this Hz? Y upon X. That Hz is basically nothing. You should all know that it is the transfer function of the system. What is that? It is known as the transfer function of the system. Okay, it is known as what? It is known as the transfer function of the system. So, ठीक है. Yz is known as Xz into Hz. Xz into the Hz. ठीक है? That is what it is. Done, everybody? Okay. Okay, chalo. So, now there is the first instant given that, there is the first situation given that the response, what is the transfer function, wo nahi given hai, but if the input is un, the response is delta n. Okay, in the first, if xn is un, okay, the yn is given by delta n. So what is the transfer function? It is given by the ratio of output by input Z transform. So what is the output Z transform? Delta n, Z transform is 1. For impulse, the Z transform is 1. For un, the Z transform is given by Z upon Z minus 1. So overall, it is Z minus 1 by Z. That is the transfer function. Z minus 1 divided by Z. Okay, now the response to unit ramp input. In the second situation, the input is given to you. That is the unit ramp input NUN. You are required to now calculate the output YN. Okay, so first let me take the Z transformation. What is YZ? Xz multiplied by Hz. Now, what is the Z transform for NUN? It is given by Z upon Z minus 1 whole square. Right? Okay. Z upon Z. Yeah, in the negative power also you can write down. Okay. Az inverse upon 1 minus Az inverse whole square. Basically simply Z upon Z minus 1 whole square into the Z transform that I just calculated as Z minus 1 by Z. So देखो, what is the YZ coming out to be? Z minus 1 एक बार cancel होगा, Z cancel होगा, answer is 1 upon Z minus 1, but I want the answer in the time domain only. So 1 upon Z minus 1, okay, let us write it as Z inverse into Z upon Z minus 1, because Z upon Z minus 1 is the Z transform for unit step that we know. So what is the output Yn? Z upon Z minus 1, it is the Z transform for unit step Un. Okay, but Z inverse, in the Z transform, Z inverse come when there is a time shifting. Okay, so time shifting by how much? Minus 1. So it is not Un, then it should be U of N minus 1. So the output should be U of N minus 1. The output should be U of N minus 1. Okay. The output should be U of N minus 1. Ramp input NUN. Done? Okay. Next question then. Consider the compound system shown in the figure below. Its output is equal to the input with a delay of 2 units. The output is equal to input with a delay of 2 units, and there is a compounding of 2 systems, that is in cascade basically. Compounding kis tarike se, they have cascaded the 2 systems. If the transfer function of the first system is H1Z, okay, then what is the H2Z? Okay, it's a simple property based question basically. Okay, what is the output of the system is equal to the input but with a delay of 2 units. It is equal to the input but with a delay of 2 units. It is x of n minus 2. Is equal to the input but with a delay of 2 units. So Yn is basically given by x of n minus 2. Correct? Yn should be x of n minus 2. Okay. So what should be the Z transform? Take the Z transform both the side, Yz, and here you have to apply the time shift property, xz into z ki power minus 2. Xz into z ki power minus 2. So what is the transfer function of the system? We know that the overall transfer function is ratio of output by input Z transform, and that is what is z ki power minus 2. That is what is known as z ki power minus 2, correct? z की power -2. Now, whenever two systems are connected in cascade, okay, whenever two systems are connected in cascade, the transfer functions are multiplied h1z into h2z. Okay, so the overall transfer function, okay, is the product of h1z into h2z. Okay, that means the overall transfer function, which is z की power -2 and h1z to given है z minus 0.5 divided by z minus 0.8 is multiplied by h2z. So what is the value of the h2z? It is z power -2 into z minus 0.8 upon z minus 0.5. Simple property based question था relating with the system. तो z power -2 को अंदर multiply करेंगे. Okay, so you should be having z की power -1. Okay, minus 0.8 z power -2, correct, upon, अच्छा everything is in negative power, क्या नीचे भी 1 minus 0.5 z inverse कर दिया है. Okay, तो no problem, from here I will take z common, so that will become z की power -3. अगर यहाँ से z common लिया तो z power -3 into z. Okay, हाँ ठीक है, यहाँ let me take the z common from both and then write down the answer for you. तो 1 minus 0.8 z inverse upon 1 minus 0.5 z inverse. Okay, and then my answer is z power -2 minus 0.8 z की power -3 divided by 1 minus 0.5 z inverse. Okay, so then answer is option number B, z power -2, correct. हाँ, answer is B then. Done है जी. The correct answer in that case is equal to the B unit. Answer is B. Okay. Moving ahead to the next question. Yeah. Moving ahead to the next question. Here it is. The impulse response Hn of a linear time invariant system, okay, is real. The impulse response is real. The transfer function has only one pole and that is at z equal to 4/3. Okay, the zeros are non-real and located at, अच्छा, located at, ये यहाँ पे आएगा, located at mod z equal to 4/3 and then the system is what? ये पता करना है. Okay, ये यहाँ से हटा देंगे. This is not required. The zeros are non-real and located at, okay, mod z equal to 4/3 and there is only one pole. अच्छा, whether the system is stable and causal. देखो, it's a good question here. Okay, the zeros of hz are non-real and located at a circle whose radius is mod z equal to 4/3. Mod z equal to 4/3, but non-real है. अच्छा, if it is non-real, it will be in conjugate pair only, na? It will be complex. Okay, they are non-real. अच्छा, that first means it is complex. But because the impulse response is, is real. Okay, whenever a signal is real, okay, then any pole and zeros of that transfer function will always be in conjugate pair. If x plus jy is a pole, yeah, 0, x minus jy will also be a pole or 0. Okay, now because Hn is real, that means poles or zeros, if complex, so यहाँ पे zeros complex है. Okay, the zeros are complex. The poles and zeros, if complex, are in conjugate pair. अगर complex हैं तो वो conjugate pair में होंगे. ठीक है? So that means there are two zeros. That means that there are two zeros. Okay, at mod z equal to 4/3. Okay, two complex conjugate zeros at mod z equal to 4/3, but it has only one pole. Okay. Given only one pole. इसका ये मतलब है dear, okay, that when you want to express the transfer function, okay, the numerator will be starting with, okay, something like az square plus bz plus c. No need to calculate something abc निकालने की जरूरत नहीं है. There is one pole and that is at z equal to 4/3. So denominator will be z minus 4/3, but numerator is definitely quadratic. Okay, degree of numerator greater than degree of denominator, then the system cannot be causal. More poles than zeros. Degree of numerator is greater than the degree of denominator. Degree of numerator greater than that of the denominator. Okay, that means, okay, system cannot be causal because this is one of the condition for causality. Okay, the degree of numerator should be less than the degree of denominator, because causal system can only contain negative powers of z. Causal system can only, after expansion, it can only contain negative powers of z. Okay, but here degree of numerator greater than denominator, if you divide even by long division method, so this is having heavier degree, so answer will be some positive power of z will come up. System cannot be causal. Okay, अब देखो pole कहाँ पे है? System is not causal. Okay, system is non-causal. ठीक है, so what can be the ROC? If it was causal, okay, then ROC is exterior of the circle. If it is non-causal, ROC will be reverse, interior of the circle. There is only one pole at 4 by 3. So ROC will be mod z less than 4 by 3. Now if mod z less than 4 by 3, okay, so unit circle is included. Unit circle is included. Okay, so the system is stable. System would be stable but non-causal. Very good question. Stable and non-causal, strictly anti-causal basically, because mod z interior hai, the mod z less than 1 by 3, it's non-causal. Yeah, to be specific, it's anti-causal primarily. The correct answer is option number D. The correct answer is option number D. Done hai? The very correct answer is option number D. Done hai? Let's move ahead to the next question then. Let us then move ahead to the next question. A signal is band limited, a signal xt is band limited to w hertz and yt is equal to x cube t plus xt plus 1. What is the Nyquist sampling rate of yt? What is the Nyquist sampling rate of yt? Nyquist rate of yt. Now signal xt is band limited to 1. Okay, this is band limited to w, sorry, not 1. This is band limited to w. Okay, so x cube t. Okay, if xt is band limited, highest frequency component w, x cube t has the highest frequency component 3w. That is a standard result, because x cube t is xt. Multiplication corresponds to convolution in frequency. When you convolve in the frequency, the durations are added. When you convolve in the frequency, the durations are added. Okay, so the total duration becomes w, 3 times convolution, so 3w. Okay, the 3w. Okay. Okay. Now, when two signals are added, then what is the highest frequency component? Okay, it is the maximum of them. So yt, okay, which is equal to x cube t plus xt plus 1, the bandwidth for yt would then be given by, okay, maximum of the 3w and w, right? Okay, this is just a particular constant term that's not going to affect the highest frequency component, as we know. Okay, so the answer is 3w. Okay, now if the bandwidth is 3w, okay, then the Nyquist rate would be 6w. Okay, Nyquist rate is given by twice the highest frequency component of the signal. Then that is 6w. Then that is known as the 6w. Clear? Then that is known as what? Then that is known as the 6w. Okay. Then that is what is known as the 6w. Okay, ji. Chalo. Simple one. Next question. For the signal xn shown in the figure, xn equal to 0 for n less than -3 and n greater than 7, that is shown in the picture also. Okay, if x omega is the Fourier transform of xn, which one of the following is true? Which one of the following is true? Which one of the following is true? Come on. Which one of the following is true? Come on. It's on DTFT now. There's a discrete time signal. Okay, x omega is the DTFT of xn. Which one of the following is true? Come on, do let me know. Chalo. So what is the value of x0, guys? Let's start checking it. What is actually the x0? X0 is basically given by the formula summation of xn. Basically given by the formula summation of xn. Okay, now what is summation of xn? Summation of all values. So -1 and 1 will be cancelled. Here also -1 1 will cancel. 2 plus 1 plus 1 plus 2. That's primarily 6. That's primarily 6. So 5 to nahi hoga. Okay. Integral -pi to pi x omega d omega. Dear, what is the formula for this? Integral -pi to pi x omega d omega is given by the formula 2 pi x0. That is given by the formula 2 pi x0. Okay, 2 pi into x0. Now, what is the value of the signal at origin? Okay, that is 2 units. So, 2 pi into 2, the answer is 4 pi. The answer is 4 pi. Okay, so this is also wrong. Okay, the phase, chalo usko baad mein nikalte hain. X omega is x minus omega. Is that true? X omega is x minus omega if xn is x minus n. You know, what is the folding property in Fourier domain? What is the folding property in Fourier domain? If xn has the Fourier transform x omega, x minus n has the Fourier transform x minus omega. So this also does not hold. Okay, because the signal is not even symmetric. Right? This is origin. Okay, this is origin. This is the y-axis basically. Okay, so is it showing symmetry? These two are identical, but beyond that there is no symmetry. Okay, so this is also wrong. This was wrong. This was wrong. The only option correct is C. But why C is correct? वो मैं explain करता हूँ. Okay. Of course, we are left with no choice. The answer is C. But why that is correct? Now, how do you calculate the phase? It's not that you have to calculate the entire Fourier transform and then comment on the phase. Okay. But yeah, there is a small logic of finding that phase. And what is that logic of finding the phase? देखो, it's going to be basically, if you just left shift this particular signal. If you just left shift the particular signal by 2 units. If you left shift the signal by 2 units, ये xn है. Okay, if you left shift by 2 units, then what is going to happen? देखते. Okay. Let y of n is equal to x of n plus 2. Left shifting means x of n plus 2. देखेंगे? Okay, so if you left shift na, you can call it as reverse effect. Rather than left shifting the signal, try to right shift the origin. Okay, one and the same thing na. So if you right shift the origin, here you get the origin. Okay, इस value को पीछे लाते हैं ना, तो I am just shifting the origin to the right. Okay, and now this is the origin. See, there is a clear symmetry now. Okay, there is a clear symmetry in the value. 1 2 1 0 minus 1, 1 2 1 0 minus 1, isn't it? 1 2 1 0 minus 1, 1 2 1 0 minus 1. There is a symmetry. There is a symmetry. So no need to sketch it up. It's an observation basically. So if you take yn equal to x of n plus 2, then that's going to be even symmetric. And also real. Because all the values are real, na, very clearly in front of you. Now if a signal is real and even, okay, what about the Fourier transform of it? Okay, so y omega is also real and even. If a signal is real and even, its Fourier transform is also real and even, and real होने का मतलब है that the phase of it should be 0. Now, since the y omega, what's going to be y omega? Yn is x of n plus 2. Shifting property if you apply, so it's x omega e raised to the power j2 omega, time shifting, again producing the phase shift in the frequency domain. Okay, so what's going to be the angle y omega? It's going to be angle x omega plus the phase of e power j theta is theta plus 2 omega, but angle y omega is 0. So I have angle of x omega plus 2 omega. So I have angle x omega equal to minus 2 omega. Angle x omega equal to the minus 2 omega. Done hai ji? So angle x omega is minus 2 omega. Okay, so that is why I told you correctly the answer is C. Okay ji. Okay, angle x omega is minus 2 omega. This is how it is. Done hai ji? Chalo. Okay. So yes guys, now the full-fledged courses for GATE 2025 and 26 are now live on the Byjus exam prep app as well as the web, offering you complete syllabus coverage in English and Hindi, both the formats, so you can choose the language of your comfort and prepare with your comfort. Okay, the courses will offer you live classes, recorded lectures, study material, mock tests, practice quizzes, everything to make you exam ready and exam perfect. Right. Okay, now to know more about the courses, you can also attend free one-to-one counseling session, and that can also incorporate complete guidance about the GATE and ECE examination. So yes, if you're looking about the complete counseling and guidance regarding to the BYJU'S course and the GATE and ECE and etc., okay, you can contact 924-133-666, or okay, if you don't want to contact, what you can do is just there's a counseling form in the description of the video. Just go to the description of the YouTube video. There is a counseling form. Fill up the counseling form. Okay, and your counseling session would be booked automatically. It's a very basic form. You can fill it within few seconds. Okay, now I'll share you the link of the Telegram as I told you. I'll share you the link of the Telegram. Let me do share it up. Okay. Okay, so I'll share you the PDF in the Telegram group. Okay, now normally all my PDFs are password protected, and I will keep the same habit. So I have directly shared the link in the chat box also, or you can join using this name provided. And today's PDF, and other than other PDFs about updates about other classes, doubt discussions, multiple things you can be involved here. Okay, so let's keep the password for today's PDF, and that's going to be how much? Let me keep up a simple password here. And aaj kya tha? Signals ka tha. I'll give a very simple and straightforward password. Everything in small. This is signals. This is going to be signals. 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 That's going to be signals. Okay. Done hai ji? Done hai. Okay. Chalo. Let's move ahead, guys. So that's it for this particular session. Okay, some important miscellaneous good conceptual questions taken from signals. Okay, now Wednesday, okay, you can attend the next session on BARC. That is going to be analog and then EMFT and all those things. So analog and EMFT, 2 more sessions in this week going to come up for you. Okay guys, bye bye. Thank you. Stay safe and do take care of yourself.